Thank you for joining us today for our ETRAGE webinar series, where we typically cover design and manufacturing topics twice a month. You can find future webinars at etrage.com under events. Today, we welcome our partners from XPLM to talk about how to manage your ECAD data within Windchill. A few housekeeping items as you review the agenda. Everyone is muted. If you have a question, please use the Q&A icon. If we are not able to answer your questions during today's session, we will follow up with you afterwards. A recording of this webinar will be available on our ETRAGE YouTube channel later this week. Again, welcome. I am Sinead Kimbrell. I am the Director of Sales Enablement at ETRAGE. Started in the PTC channel 11 years ago and have worked in adult education for over 20 years. With me today is Mark, the Director of Sales and Business Development at XPLM. He is an electrical engineer by trade, was at PTC managing ECAD products from 2004 to 2015 and has since then been at XPLM. A little bit about ETRAGE. We are a software development company. We have been partnering as a PTC technology partner for over 20 years. Our mission is really to help customers adopt PLM, and we do that through identifying gaps in your infrastructure as well as user concerns. We are able to extend PLM data from the engineering department throughout your organization and including vendors that work outside of your organization. We're able to integrate enterprise systems, migrate data between systems, and automate design process to allow data to flow again from your design and research team all the way through manufacturing. And our team is global. We have folks in North America, in Europe, as well as in India and Asia. A little bit about the solutions that we provide to help that PLM adoption. Our software products include ETRAGE Viewer, ETRAGE Publisher, our doc management system, as well as different connectors to be able to make sure that your enterprise systems are able to talk to each other. If you're interested in finding out more, we do have past webinars available so that you can review those products. Additionally, in our services, we are able to customize apps to extend the how you're using Windchill. We can host your Windchill and Creo licenses and provide support through our help desk, our ability to customize your systems. We can upgrade your systems as well as do migration. Additionally, we do offer PTC, Creo, and Windchill training through our public classes, through our e-learning, as well as any private on-site classes that you may want to have instructor and led training. Today, we are joined by XPLM. They are also a global company looking at how companies can get more out of their PLM system and connecting all the different enterprise tools that you're using to make sure, again, that your data is flowing through departments and getting into the hands of those who need it. I'm going to turn it over to Mark now. He's going to walk us through how you can use XPLM to better use that data and make sure that folks are getting what they need.
Okay. At XPLM, we focus on ECAD and MCAD integrations to PLM systems. And today we'll be talking about a mechatronics story with a focus on, the ECAD users. And we've got a fun story. So what's typically a pretty dry presentation of putting data into the PLM system, is has a fun little story around it. Apparently, this is a real problem coming out of Germany. So XPLM is a German-based company. where deer were getting caught, the old saying, a deer in headlights. We're out in the field just staring at the combines. And you can imagine what was happening there. So the idea here is that we're deploying drones to look, for deer in the fields before the combines come through. And we'll talk about what went wrong in our drone deployment process and how it was solved with XPLM and PTC software. And I've got a nice little a video demonstration I'll be going through near the end of the presentation. Okay, so designed to operate, basically you're looking at the drone here, right? Inside of that drone, you have a printed circuit board, a connector with, maybe that's a harness connector that was done in a separate CAD tool from the printed circuit board itself. You've got you've got the housing, right? The mechanical CAD structure and the drive structure. So again, that's more of a mechanical thing with the drive. But all those things come together to build your product. In the case of the story here today, there's a connector on this board. And the story is, we're in the middle of building these drones at Acme Corporation here, and that connector is no longer available. And because of that, the company is going to have to pivot rather quickly to make a change, find a new part to use, and make the change to all the design data and get that data out back to the production floor. So, when it comes to building a product like this, you do have many disciplines, and that means many different people, right? And it's not just the people in design, it's the people in purchasing, it's the people in manufacturing. And the only way you're going to build this product the way that it was originally intended to meet customer needs is if all of these people are working together. And a single part change, as we're going to do in this example here, it affects everyone. It affects the person that has to buy that component. It affects how that component gets placed onto the printed circuit board through the PCB manufacturing process, right? It could affect the MCAD assembly, right? Because that component might, the replacement part might be too big and collide with the mechanical CAD structure. So there's a lot of people there, and of course the ECAD guys have to change it in their design, right? So a lot of people are affected by a single change. Right. So within development, you've got the end-to-end process. You have to make sure that the mechanical product structures are all updated inside of your PLM system when you make a change like this. And you need the right backbone to support such a massive change. It's a single part, but it's massive because it touches so many people in the company, right? And so how do we accomplish this part change successfully and quickly? And that's what we're about to go through here. Just kind of like to lay the groundwork, like who's talking to who within the company to make stuff happen. And I don't know, you start with a plan, right? You're going to then put a design together. You're going to produce that design, you're going to deliver it, and there's someone out in the field operating on it. Right, so I guess just by the way I went through this, the circles probably should have been different spots, right? But that's kind of the way you think of a design, and then maybe after it's operating in the field, some information goes back to the designers to make changes for Rev 2. Right? In reality, it probably ends up looking more like this, though, right? Where these different people and different groups that are building this product need to talk to each other more than these lines indicate, right? It looks more something like this, where it's it's kind of all over the place. And when you get this change, a massive change coming, that massive change is going to impact all of these people, and everyone needs to be notified. So within a PLM system, you will have or see your source of truth, right? So your requirements, your MCAD design data, supporting documents, ECAD design data, software are all nicely saved inside of Windchill, inside of product structure. And because it's all in that single system, it makes a great system to say, we're going to introduce a change request inside of Windchill that impacts, all of these different domains, because everything comes together here. Just to kind of show you a little bit deeper, when you're looking at the engineering BOM, right? You've got your ECAD design, okay, and then there's this one component that's has a chip. This chip has a firmware on it, right? And then that firmware is tied to that component. And then here's your firmware, and the firmware has some bits to it. And then you've got your mechanical structure, and somewhere inside of your mechanical structure, you've got your ECAD assembly, right? And that's this guy right here is going to be showing right here. And when you put it all together, this is the BOM you're going to see, a consolidated engineering BOM inside of the PLM system with everything all connected together. Now, other ways to do it, yes, you don't need to, it doesn't need to go like this. It could actually be a little bit more flat. Like, there's different ways to configure it, but this is like a nice view to really show the full structure of MCAD, ECAD, and software all kind of together. Now, once your designers that are using ECAD, MCAD software tools put their data into the PLM system through some means, then it enables people outside of engineering access to the design. So the person inside of purchasing that needs to worry about the part going obsolete and finding, making sure that there's a new part being bought, right? They can look at the BOM and determine what the new part is, right? Just an example that we'll be showing in our use case today. But all of these other people, R&D is there, but sales, purchasing, legal can look at it to see what bill of material looks like. Everyone that needs to be involved can get access to it through the PLM system. All right, here's the fun part. Now we get into the demonstration to show, what happens when you have a significant part change within the middle of trying to get a product out the door. Okay, so we're working on our drone, and we get this email. Now, please excuse the English in this. This native German speaker wrote this, but it's very simple. We're getting a notice from the supplier saying this part's no longer available. Okay. One thing you have to keep in mind as I'm going through this presentation is that the video is going to be representing multiple hats. It's not all the electrical engineer that's doing everything you see. I will do my best to say, hey, now I'm the component engineer, or now I'm the person in purchasing, when you're seeing different things, just to kind of level set who will be doing what in this video, because it's kind of jam-packed with a lot of action. So I'll try to pause it along the way as well. All right, so someone in purchasing probably received this. Hit play. Okay, here we go. This email, right? And that means we're going to do a change notice internally, right? And we need to let all the different teams know that there's a change happening. So what do? We go to our PLM system, we look up the connector. And there's the connector in question that we got the email about. You can see that the status of that, it is currently a release part. And we're introducing a change notice. By the way, the release status is shown right here. Okay, and we're creating the change notice. We're letting people know that this part is being obsoleted. We're submitting that change. Now, depending on how your workflow is set up, different people would be notified of the change, right? In this case, now we're going to set this as a release part to a canceled part. Now those states right there, those are all configurable. You might have something called, end of life. It might not be called canceled. So whilst that was happening, off in purchasing land, person creating a change, we're now just the electrical engineer doing our daily work, okay? And we're checking in, well, actually, we're first looking for the quadcopter design that we've been working on for the last couple of weeks. We're loading that up from Windchill into our local machine. Okay, so this is using the integration to pull a design out of Windchill, loading it into Altium, which is one of the many ECAD tools that the integration supports. And now we can work on our design, and we can see that there's a schematic and a printed circuit board. And on the right of that board is the connector that you're gonna, we'll be talking about. But at this time, we're just doing some routing, right? We just created a route. We're making some changes to the design. We're showing it in Altium's 3D viewer, right? Everything's fine as far as we're concerned. We're just an electrical engineer doing our daily job. So we go to save our design change that we just made, which was really just that routing change, right? But we're going to generate all of our manufacturing outputs because we're near the end of this design, and we want to put them all into the PLM system. You're seeing a BOM comparison that comes up now because we're checking in a bill of materials. And in that BOM comparison, there's some nice things on the bottom there that show you what's added, changed, modified, removed. There's tabs though as well. And in this tab, we see that there is a part that's been canceled. So if I try to continue with my BOM check-in, it's saying, no, there's a part that's obsolete. You got to go take care of that. So I'm going to pause it here. If I was a more diligent engineer, I probably would have been paying attention to my emails, and I would have seen the change request come in from my purchasing person, right? Remember that change request that we already did in PLM? I didn't, though. I kept on working. But you can see how the integration has built-in protection to prevent me from continuing to use a canceled part. So now that as an electrical engineer, we know there's a part that's been, canceled, obsoleted, whatever word you want to use, we need to pivot. We need to make a change. I believe what we're doing now is we're going into PLM and we're looking at the design structure, the BOM from the PLM perspective of the last time it was checked in. And we're just looking to see, was this part really canceled? And yeah, it's sitting in there. It's got a canceled state on it within my BOM. And I could see the fact that there was a change request on it. So what am I going to do about it? I'm going to go into my CAD tool and I'm going to change that part. I've changed the part, I've rerouted it. And if you remember what the old connector looked like, this connector looks different now. We've replaced it with a new part. So what do? We save that design back into PLM. It'll overwrite the old BOM with the new BOM that contains our new part, right? And you can see through the BOM comparison, it's removed the old part. And you'll just zoom in on that, right? It's removing the old part and it's adding our new part. And just try to remember the new part in the middle there is the MPC4 because you're going to see that come up quite a bit. So the MPC4 is the new part. Now, when it comes to adding parts to Windchill, you can either add the parts to Windchill first, the new part, or through the part synchronization process that we have, you can add the part in CAD first and then have it synchronized to Windchill, and then it will add the new part in Windchill. And that's what you're seeing here. This part exists only in the ECAD library, the MPC4 right now. The engineers created it. And through the synchronization, which he's running right now, watch what happens. It's created a new part number up here, this 1099 inside of Windchill, and it's synchronized the attributes on that part. So that part now exists in Windchill, and he's going to show you the 1099 exists. It was just created at that very moment. And this is completely customizable. Like, you can always start your new parts in Windchill and have them sent to the CAD library, or in this case, you can start in the CAD library and have them sent to Windchill. So it looks like we're just warning purchasing of the new part that we created. There'll be a part workflow for that new part anyway. It's not instantly set to released. It'll be set to, in work. So we're just searching. We're showing the new part inside of Windchill here, the MPC4, and we're going to set it to released. Right now, who's doing that? Not the end engineer. that's happening along the process of your new part introduction process. But, so we're wearing a different hat at this point of someone who's actually releasing the part. It's gone through a workflow. Component engineers check to make sure that it wasn't duplicate, all that good stuff. So what we did there was we just updated this design against the latest library that has a new part in it. And now we're uploading the BOM yet again. But this time you can see there's removed and there's an added part. So that part's no longer a missing part. It's added because we synced it to Windchill. And this time you'll see the BOM gets fully checked into Windchill with our new part in it. Now keep in mind, this is just one discipline working on this, right? The engineer has found the electrical engineer has found the new part to use. Using the new part, he's the person has been notified in purchasing of what the new part is, but we still need others to see this new part, and that will happen now that the engineers put this into Windchill. The next step would be for the mechanical engineer, which he's warning right now that the design's been updated. Please make sure that the new part we put in to our ECAD design is going to pass the form and fit tests or interference checks that you run inside of your CAD tool, your MCAD tool. And that's essentially where the video ends, right? So we didn't take it all the way to the point of notifying manufacturing of the change as well. We kind of left it with the ECAD guys made a change. Now MCAD can go check to make sure that that change was good for him. And the process continues until everyone has approved that new part change. Purchasing's purchased it, and then manufacturing can be notified to go build it. Go build these drones so we can go save Bambi. So that is the end of the video. So conclusion, it really is an end-to-end process. And then when a change comes in, like a part has changed in the middle of the design process, what do you do, right? And I think that this demonstration here gives you a good idea of how PLM is used as the backbone to control the change. The CAD tools are tightly integrated into the PLM system, allowing changes that are made in the CAD tools to be reflected back into the PLM system for people to approve. And you can see the EBOM and the MBOM. So the EBOM is the engineering BOM. That's what you're getting from the CAD tools, right? Before it gets manipulated in PLM to become an MBOM if you're doing that in PLM. The automation, the ability to do the library synchronization so that you didn't have to manually type in all the information inside of Windchill about the new part. And in the library, you do it in one place or the other. The automation helps make this process a lot more smooth and helps with the fast communication between, design groups and just to make this change quicker. At the end, we really didn't show the ECAD MCAD collaboration piece, but you can imagine that the MCAD guy didn't just get an email from ECAD. He probably got an IDX update that showed the new component being added, and the IDX file could be loaded into the MCAD tool to change the actual component that's being used to the new connector. And with PLM being used, you get the value of the history of everything that's gone down here. The uprev of the design, if it was already released, all that stuff. In this case, it wasn't already released, so there was no need to uprev it to a Rev B of the design. We just continued with the Rev A and made changes there. Okay, so that's it for the presentation today. I'd like to thank everyone who joined. I believe that we are taking questions inside of the webinar. If there are any questions we can answer right now.
All right. I will share my screen one last time. And this is my contact information. If you do have any questions about ETRAGE or XPLM and ECAD data, managing it within Windchill, we're happy to help you out. For future webinar topics and dates, again, please visit etrage.com, and we'll see you next time.